I'm Anil Kumar, and in this video we are going to discuss remainder theorem in details. So this video can be a bit longer. Remainder theorem states that if I divide a function which is a polynomial by, let us say, x minus a, in that case remainder is value the function at a. The remainder will be f of a, right? Now if you are dividing by a linear factor which is kind of let's say px plus q, right? In that case remainder should be f of let's take minus here. So whatever makes this 0, it should be q divided by p, right? So that is what the remainder theorem is. So we can take up an example just to show it. So let's say we want to divide x cubed minus 2x squared plus x minus 1 by, let's say, x minus 2. Okay, let's divide this by x minus 2 and see what do we get. So first we have to multiply by x squared, so we get x cubed minus 2x squared. Well, that gives us 0. So it's a good idea to bring both of them down. It's a special case. When you bring x minus 1, I can now multiply by plus 1. We get x minus 2. And the remainder in this case is minus 1 minus 2, which is plus 1. You could also check the value by using remainder theorem, right? So that is to say the polynomial is x cubed minus 2x squared plus x minus 1. So if I write the value of this polynomial for x equals to 2, in that case what do we get? So we are substituting 2 in this equation, x cubed minus 2x squared plus x minus 1. So it becomes 2 cubed minus 2 times 2 squared plus 2 minus 1, and that is 2 cube is 8 minus 4 times 2 is 8 plus 2 minus 1, and we do get 1, the same remainder, correct? So we get the same value. So instead of doing long division, or you can do synthetic division and finding the remainder, we could always use remainder theorem to find the answer, right? So let's take another example and let's divide by a binomial which has a leading coefficient not equal to 1. So let's take example to divide. I want to take very simple examples. Let's say just 4x squared minus 2x minus 3. And let's divide this by 2x minus 1. So we can multiply by 2 here. So when you multiply by 2x rather, you get 4x squared minus 2x, and both are 0. You get remainder of minus 3. Do you see that? Now if you use remainder theorem, you can find the value of this function. Let's say f of, what you should place here? Half, right? 1 over 2. So substituting 1 over 2 in the given function, we get 4 times 1 over 2 squared minus 2 times 1 over 2 minus 3. That gives you 4 times 1 over 4 minus 2 divided by 2 is 1, and this is minus 3. This is also 1. So 1 minus 1 is 0. You do get minus 3, right? So we get exactly the same remainder once again. So that confirms the utility of remainder theorem. So as you can see from here, if the divisor is a linear function, in that case remainder or dividing the polynomial will be the value which makes that divisor 0, correct? So that's the whole idea. Now as a practice question, let's write down a question for you and we can just find remainder for those questions. So let me write down, let's say x cubed minus 2x squared plus x minus 5 divided by x plus 1. So in this case, what should be the remainder, right? You have to find remainder. Right? So you can find remainder, and the way to do it is not by long division. You should use remainder theorem. Substitute minus 1 here, right? To find remainder, you can say remainder is equal to value of this function when x is minus 1. So we substitute minus 1 for x cube minus 2 times minus 1 square plus minus 1 minus 5, right? Minus 1 cube is minus 1. That makes it positive, so you get minus 2. Here we have minus 5, and then, I'm sorry, I missed this minus 1. Let me rewrite. So I just swapped these positions. I wrote here and there. I first wrote minus 5. So the answer for me is minus 3, 8, and 1, 9. So minus 9 is the remainder when you divide the given function by x minus 1. Let's have another question where you could divide it by something like that, right? So we have here 2x to the power of 5 minus, so I won't do this, it's more complicated. I'll leave it for you to do, x cubed plus 3x minus 1. And let us say we are dividing this by 2x minus 1, correct? Now, the remainder should be equal to what? Value of this polynomial, let's say f of half, right? Half will make this 0. You can substitute half here and then figure out the answer. So that is going to be the remainder for the given equation, right? For simple calculations, let me change this value to 32 because 2 to the power of 5 is 32 and cube is 8. Let me make this 16 so that you don't land up in fractions, okay? So maybe here you'll have fractions. Let me make this as 1.5, okay? So if I do some modifications, it doesn't really matter much, but it's a practice question. You can always find remainder by substituting half for x. No need to do long division, right? So that's the gist of it. So we have understood what remainder theorem is. Remainder theorem basically states that if a polynomial is divided by x minus a, you may get some quotient, but the remainder is value of that polynomial at x equals to a, which is f of a. And if you divide by p x minus q, remember we can write px minus q could be p common x minus q over p. That gives you the connection. Do you see that? So the remainder will be value of the function at q divided by p, right? So let's continue from here and do some application questions based on remainder theorem. This is a very popular question which I am taking now. Let us say that we are given a function f of x which is equal to x cubed plus kx squared plus 2x minus 3, and when this function is, when f of x is divided by, let's say x plus 2, then remainder is 1. Question is find the coefficient k, right? That's the question for you. You can pause the video, answer the question, and then look into my suggestions. Now applying remainder theorem, when you're dividing by x plus 2, then the value of the function at minus 2 should be equal to remainder, right? So we'll substitute minus 2 in the function, which is minus 2 cubed plus k times minus 2 square plus 2 times minus 2 minus 3. And this value should be equal to 1 since 1 is the remainder, right? So we say 1 equals to minus 2 cubed is minus 8, and that gives you plus 4k minus 4 minus 3. So what we have here is minus 8 minus 4 is minus 12, and then we get minus 15 plus 4k is equal to 1. Bringing it to the left, 15 plus 1 is 4k, which is 16, right? So k is equals to 16 divided by 4, which is 4. So that is how we can find the value of k in the given function, right? So we have our solution that k is equal to 4. Let me also share with you another very popular question. So let's divide the page. Sometimes there are two unknowns, right? So this time we'll deal with another situation. Let me write the question here. I'll write solution on this side. Question 4 is, let's say we have a polynomial p of x, which is equal to x cubed plus mx squared minus n, right? Let's say that is the polynomial given to us. And when you divide the polynomial by x plus 1, remainder is equal to minus 2. I'm writing in short. And when you divide this polynomial by x minus 2, the remainder is 13, right? Remainder is 13. The question is to find m and n, right? So that is the question for you. You can always pause the video, answer the question, and then look into my suggestions. So let's see how to solve this question. Since we know the remainder, we can apply the remainder theorem. So p of minus 1 should be minus 2. So we begin by writing, let's say, solution here for question 4, right? Okay. So p of minus 1 should be value the function at minus 1, right? So I'll substitute minus 1 for x in the given equation. So we get plus m minus 1 square minus n. P of minus 1 is the remainder, which is minus 2. So we get minus 2 equals to minus 1. This is plus m, and that is minus n. So we get, taking this on the left side, we get minus 1 equals to m minus n, right? So we'll call this as our equation number 1. Two variables, unknowns, we need two equations. Now we'll find what is p of, when you divide by x minus 2, we are looking for the value when x is 2. Substitute 2 in the given equation, we get 2 cubed plus m times 2 square minus n. P of 2 is the remainder 13, so we get 13 equals to 8 plus 4m minus n. So 13 minus 8 equals to 4m minus n. That is 5, so 5 equals to 4m minus n. Let's call this as our equation number 2. Now, minus n, we could do elimination. So let's eliminate. So we'll do equation 2 minus equation 1. So we'll take away from this equation that. What do we get? 5 take away minus 1 is 6, right? So we get 6 equals to 4 take away 1 is 3, so 3m. Minus n take away minus n is 0, so 3m is 6. 6 divided by 3 is m, which is 2, right? So we get the value of m, and now we can find n also using equation 1. So we'll put m equals to 2 in equation 1, correct? So if I write 2 here, I get minus 1 equals to 2 minus n, bringing 2 to the left side. Minus 1 minus 2 equals to minus n. That is minus 3 equals to n, or we get n equals to 3. Is it okay? So we get our solution, and the solution is that m, in this case, let's write down m is equal to 2 and n is equals to 3. Is it okay? So m equals to 2, 3 equals n equals to 3 is our answer. So that is how we could actually solve for two unknowns if we know remainder by two different divisors. I hope that helps. So remainder theorem can help solve many situations as we just thought of. In all the examples which we have done so far, we have used remainder theorem when we are dividing by a linear term. What happens when you divide it by a quadratic function? Can you use remainder theorem? That is what we are going to do next. So the next example here is, the last question for the series is that determine remainder when let's say the function is x cubed plus 3x squared minus x minus 2 is divided by two factors, x plus 3 times x plus 5. Now how are you going to solve this? Using remainder theorem. Okay, you can always do long division and find the remainder, but how are you going to apply remainder theorem to get solution of this question? That's the question for you. You can pause the video, answer the question, and then look into my suggestions, right? Now here I'll show you a very important technique and also the application of division statement, right? That is going to help us in solving this equation. So let us say when you divide this function f of x by x plus 3 and x plus 5, you get a quotient of q of x, let us say, right? So we can write division statement. So let's begin with division statement. That is to say that this particular function, which let's call this as f of x, is equal to, let's say quotient is q, then x plus 3 times x plus 5 times the quotient plus the remainder, right? Remainder. So that becomes the division statement when this is equal to our function. Is it okay? We need to find remainder. We are not worried about the quotient part. Now first question is, if you divide by a quadratic function, what could be the remainder? Well, it has to be a degree lower. So let us say that r of x is equals to a linear term ax plus b. Is it okay? So let's say r of x is ax plus b. Perfect. So we'll replace r of x with ax plus b in our question. Second, let us also find the value of the function at minus 3 and minus 5. So let's find the value of the function at, let's say, minus 5 first. Okay. So I'll substitute minus 5 here. We have minus 5 cubed. We may need a calculator now. 3 times minus 5 square minus of minus 5 minus 2. How much is that equal to? So let's find this value using calculator. Minus 5 cube will be negative, right? You know it's 125. Okay. Anyway, let's use calculator. So let me write this as bracket minus 5 cube. Okay. Plus 3 times within bracket minus 5 square minus within bracket minus 5 minus 2. Okay, so that gives us minus 47. Okay, let us also find value of this polynomial at minus 3. So we'll just change these values to minus 3, same equation, correct? So we say minus 3 and then move forward. Delete minus 3, move further forward. Okay, so delete minus 3 and that was it, and then equal to. So it's equal to 1, so we get 1. Okay, so at minus 3, let me write here, f of minus 3 is equals to 1, right? That's what we got. Perfect. So we just found the values of this function at minus 5 and minus 3. Okay. Now, let's continue with our question. We are seeing f of x is x plus 3 times x plus 5 times quotient plus r of x, and we'll replace r of x with ax plus b. Since we are dividing by a quadratic function, remainder can be linear. That's the maximum degree, right? So let's find, if that is the statement, now let's plug in minus 3. What happens? See, if I write minus 3 here, then x is minus 3 plus 3, x plus 5 times quotient, let's write value minus 3, plus r of x, which is a times minus 3 plus b. So what we did was that in our division statement, we replaced x with minus 3. Now minus 3 is 0, so this part is 0 for us, right? But f of minus 3 is known to us. We just calculated that to be 1. So we can write 1 equals to, this part is 0, and we get minus 3a plus b. Do you see that? So we get an equation relating a and b. Similarly, we can find what is f of minus 5. Minus 5 is substituted in this. What do we get? We get minus 5 plus 3 times minus 5 plus 5 times quotient minus 5 and plus remainder a times minus 5 plus b. Now as you can see, this portion 0 times anything is 0. F of minus 5 we calculate as minus 47. Since this is 0, we are left with minus 5a plus b. And this is our equation number 2. So we have these two equations to work with. Two variables. We can always find the value of a and b, correct? Once we find a and b, we know what remainder is. Is that okay? So now what should we do? So let's continue here. Now we'll continue on this side. So we can say do equation number 1 minus equation number 2. That's the first step. Equation 1 minus 2 will give us minus 41 minus 47 gives us 48, right? Equals to 1 minus 2 gives us 2a, right? b minus b is 0, and that gives us the value of a as equals to 24, right? 48 divided by 2. Now, from the equation this, you could also say b is equal to 1 plus 3 times a, right? Let's call this as equation 3. Since a is 24, what is b equal to? b equals to 1 plus 3 times 24, right? Which is 3 times 24 is 72, 1 plus 72, which is 73. So with that, we get the value of a and b, right? So a is 24, b is 73. So what we get here is the remainder. So the remainder is, which was ax plus b, now can be written as 24x plus 73. Is it okay? So that is the remainder, right? So that is how you could actually solve questions where the divisor is not just a linear factor but a quadratic one. I'm Anil Kumar, and I hope that really helps. So in this series we learn a lot about polynomials, division statement, and now remainder theorem. We'll take a few more videos where we'll discuss factor theorem and some real life situations. I hope that really helps you to understand the whole unit. Thank you and all the best.